Good morning. I hope you can hear me. Hope you have a good holiday. Just a reminder, probably you might have noticed already, is the homework 2 is already there for topic 2 for the firm. And I guess the requirement, what we do is just 9 questions. I hope that should be not super difficult. I mean, probably just like extending what we have in the lecture slides. We have 2 input, but now we have 3. I mean, you can easily see, you can generalize to general number of n without any issue, but let's do 3 first. And then for the optional, they're more fun. I mean, you can try to look at those if you have time, but I guess it's just the requirement would be the thing that I would like you to have good knowledge on those. So the goal today is that we hope to finish the equilibrium, which consists of 2 different parts. The first part will be the partial equilibrium. We will talk about how firm compete, right? The first one is perfect competition. We covered last time, so we will review it a bit. And we will consider only single firm, so we don't only talk about how they compete. Instead, we just have only one firm facing the whole market. What will we see? We also cover that, so we'll review a little bit. And the following 3 would be possibly you might use it when you do modeling. It's 3-way. Probably you might have heard that. The first one is Cournot, which is just saying a quantity competition. So firm is deciding quantity, and it's imperfect in the sense that how much you're producing depends on how others are producing. So and firms are allowed to choose whatever quantity they want, and at the end, no one wants to change it. Then it's the result of that equilibrium. And we'll be make more precise what do we mean by that later. And Bertrand competition is competing in the sense of price competition. And in general, Bertrand Cournot usually you can say is a quantity competition. Bertrand is a price competition. But usually we use in more specific cases where firms are producing homogeneous goods. So at the end, probably you remember from your intermediate class, you get price equal to marginal cost or average cost, depends on what you're looking at. And that would be the horizon, right? So that would be the result. The last one will be monopolistic competition. Also, you learned it from your intermediate or principal class, which is you may say is a generalized version of Cournot and Bertrand. Actually, they compete both in price and quantity, but because of a downward sloping demand, basically just like whether you allow them to choose price or quantity the same. So so that would be the basic thing, and you can easily imagine that in the literature of IO, and there will be more than several dozens ways how firms compete. We just focus on 3. It's not because others are not important, but they are easier to do and also very common. Okay, for things for those who do empirical, then probably one thing we omit here is what we call discrete choice model. And I used to give it as an exercise, but I guess this year you guys are pretty busy, so I just don't talk about those. And I would probably put them as optional assignment. I just put the question, and then after 2 weeks I give the answers. So if you're interested in doing it, you can do it. Otherwise, you can have fun reading those. Okay, because I don't have time to go over that, but I think it's very important to know it because you read the papers, then they may be there, and that is people do it for empirical things. So I just release it as you want to do it, don't do it, do it. I mean, after 1 or 2 weeks later, then I will give out the answers. Okay, so that is, I don't grade it, you don't need to submit, just you do, you don't do. Okay, and hopefully today we also cover the general equilibrium. As I said, that is a very huge topic in economics in old days, and also still a good topic, a big topic when you do finance. So asset pricing is the idea of general equilibrium in the stock market, where there are many prices, right? And then you want to see whether the equilibrium exists. Okay, but the time we just focus on the simplest case, and we'll try to show you that using price as a way to allocate good actually lead to good outcome. That's what we have, the first welfare theorem and second welfare theorem. And we'll talk about those today, hopefully. I mean, I was able to finish all. If we have time, we'll do uncertainty, but I doubt we have time. So just very quickly review what we have done last time. So perfect competition, just to remind you that what do we have is like we have M customer with Marshallian demand, downward sloping, and summation of each one give to market demand. Okay, and if you look at the tradition of, say, the Chicago School of Economics, and they would just directly start from this market demand, down sloping, and then that's how they start everything. But we can start from constructing from individual. That's what we learned in topic 1 and topic 2, right? And look at the firm. He faced the input prices, and we have the output supply function and aggregate them. You got the aggregate supply and also the profit function, right? So you got the aggregate or industry supply, and here we just define, okay, and that is basically what economics we emphasize on, is using the price to solve this demand supply problem, right? You have two agents and how they transact, right, is rely on price, right? The price is freely adjusted so that no one want more than what they want. No one is going to supply more than what they want to, then it's equilibrium. Okay, so that is do note that this hints on the idea that price can freely adjust, right? Because that is what we call the market mechanism, right? Because if price is not freely adjusted, then this is not what you observe, right? Suppose, for example, here in this case, we assume the price faced by the consumer is same as the price faced by the firm, right? Suppose a tax, then you have some changes, right? Suppose a tax is charged on, say, sales tax, right? Which doesn't exist here, but exists almost everywhere in the world, right? Look at Singapore, China, US, Europe, right? And consumer actually have to pay more than the P star, right? Maybe P star plus T, right? Then for you to solve this model, you have to add T there, right? And because the T go to the government, and but the seller doesn't accept T. So that's a many different kind of variation to those, right? But actually, you can see the simplest model in this framework is the price would adjust, and we don't tell you how to adjust, right? But we just I mean, of course, as we said in the last time, right? The adjustment comes from the fact that people optimizing, right? And they would be, if they have excess demand, right? Then they are willing to pay more than they do, and then firm are willing to supply. So that's why the imbalance would cancel out. Okay, at least in the long run, right? This look at is like, although here say short run, right? The adjustment process for this to occur can take a long time, right? Even though consider the case with iPhone, right? iPhone, you would at least take 1 month or so, or at least, right? Every time they have a new generation, at least take 1 or 2 months before you can actually freely buy it from the store. Otherwise, you make an order, you have to wait for a few weeks to get it done. So you can see this is although it's a short run, it takes a time for them to adjust. Okay, so this this is an important assumption in this model. Is like we assume the adjustment is possible in the long run. There's no one want to change, and that's why we define equilibrium in the sense that if the market start from this condition, okay, it remain at this condition. That is the idea of equilibrium. Okay, usually doesn't tells you if not equilibrium, what happened. Okay, usually we don't care about that. That would be another issue. Okay, the equilibrium is just in the sense that if it start there, you'll be there. Okay, and to study what happened if not there is another topic. Okay, so we talk about stability, we talk about dynamic adjustment, those kind of things. Of course, this is the central theorem in economics, so this is a well studied, and we know that this is stable. We know that one adjustment rule already. In the short run, in this case, actually, why the short run is because the price, okay, is above the AC curve, okay. So that means that firm is making profit, okay, and there's no problem making profit. If you imagine there's an entry barrier in this model, right? You can consider the case where these firms are controlling the resources like oil, right? The petrol is controlled by several countries that can produce oil. In that case, I mean, this is as well as long run. Okay, short run here doesn't actually, in sometimes can be a long run, right? If there's a no entry barrier, then with the entry barrier, then short run will also be long run. Okay, and here in terms of long run, we define the sense that there will be firm entering, and there's no cost of entering, right? The zero cost of entry. That makes we have number of firm end up is J here. Okay, it will end up in zero profit. Okay, do note that this is the result of several things. First is if there's no entry cost, that must be this case. Okay, and here we also omit the integer constraint. Okay, because here in the sense that if entry is costly, right, and you have to pay a full cost to enter, like $10 to enter, and the profit now is like $9.90, right? Then you will still not enter, right? But if you allow the partial entry, then that is possible, right? But that's not, right? So it's not divisible the entry cost. Okay, and later you will see when we talk about Cournot, then you will be more clear what do you mean by what the integer constraint in this framework. You'll be more clear when we talk about Cournot. But let us this is the classical definition about long run. It's like low entry exit, right? And we learned from the B school, right? A lot of case actually we have entry costs. There's so many things in this world that do not allow free entry, right? And actually what you're doing, the PhD, is like the entry barrier, right? It's an entry barrier for everyone to be a professor, right? And B school knows how to do it, right? Compared to econ, right? So look at how many classmates you have, 1 or 2, at most 3, right? This is how B school restrict entry to the profession. Compared to economics, right? You have free entry, so people believe it, right? So that's why you have huge number of econ PhD everywhere in the world, right? That's drive the econ PhD salary very low compared to business. But these days, probably you would know that it's already, the market is so saturated. Even the B school now, PhD have a employment issues, right? So marketing used to be one of the area that's not so saturated, but now finance people, I mean, just go there as well. And engineering and mathematics people go to B school as well, right? Because of the thing. So B school PhD student, like many of you, now facing a much tougher, right? Because in the long run, right? In the long run, in the short run, you still have profit, right? In the short run, still have profit, right? You still have some profit here, right? And now because of everyone can shift, everyone can move, right? In the long run, all the profit will be gone, right? So I mean, you don't believe it, but actually that's what happened, right? People would believe that there's some create some entry barrier. We know, right? Because like a lot business school know how to do it, right? A lot of certification program, a lot of way you just hire your own people, but at the end you have to face the global competition. So anyway, so zero profit at the end that would actually occur, right? If you have a free entry, right? And same as what will happen is when you have a free entry. Look at the also look at labor economics. Look at what happened to Taiwan. Look at the salary. If you try to look at the salary of the graduate from Taiwanese people, actually they have been stagnant for more than 30 years. Okay, and you try to look at the reason why that would happen. I mean, you look at the salary that actually say in the high-tech firm in Taiwan, they're earning the same salary as in the US because they're competing, like 台积电. So they're earning the engineers for the semiconductor, they earn same salary in the US. But the rest, they earn way much lower than that. And one of the reasons why is because of, I mean, many reasons, but one of the reasons I would say is the result of the degree inflation in the early 2000. So basically, they just allow every single people who want to make a college to make a college. So it expands on the college like 3 times, right? So there's a premium become a college graduate, but if you keep printing the degree, at the end of the day, then you depreciate, right? You keep, there's a benefit of being a graduate, and you keep going on, then you're done, right? You also look at China. Many of you have know very well, right? Before the 70s and 80s, right? They very limit the number of graduate college degree, right? And after early 2000, right? There's also huge expansion of the higher education, right? So, and also the expansion of the urban, suburban, right? So that makes college degree depreciate a lot, right? So that would happen, right? When we end up with free entry, right? And same, right? That's why when you see there's a lot of price of electronics go down so much these days, right? And that is because free entry, right? That's why there's a lot of factories in China can actually produce, and they produce a huge quantity, right? That's why they said everything, whenever Chinese firm go to, become a cabbage price, 白菜价. So that is what happened, right? Because of entry is free. Why is the case? Because why only cabbage price only appear in China but not elsewhere? Because in China there's a labor supply is the price for labor cheap, and there's a regulation wise is much more relaxed, right? So compared to many places, a lot of regulation to you cannot do that, you cannot do that. But in China, a lot of things still relatively free. But anyway, not to comment too much about the real world. So that's what you see is the price equal to AC. Okay. So in the long run, as I convinced you that if you allow enough time, then at the end that will be gone, the rent. Okay. So possibly you also can see that, I mean, the recent 10, I mean, just one more side note is recent 10 years, you can see there's a huge rent going into become a programmer, right? You look at how many training you need to become a programmer, you look at the salary, then looks like being a programmer has a more return than doing the PhD, right? And that can be true. That is true. I mean, if you look at the salary path, right? But sooner or later, actually, we know that, I mean, this excess rent will be gone. And you see actually in China right now, I mean, there's a lot of people who are doing programming, it just go lay off and go like the US, right? Because in the long run, this kind of excess surplus or excess profit will be gone because a lot of people would get in anyway, right? And in that case, no one can make any more profit out of it. Okay, but so let's consider monopoly just very quickly. And monopoly is a downward sloping demand, and then basically you face a downward sloping demand. So basically just like the single firm and who look at the downward sloping demand and decide what's the quantity, and that is the cost, right? This is a revenue minus cost. So in here, I just decide the Q, but you can reverse it, look at the decide the price. You can just do that as well. You can just like maximize price, right? P times you can have a demand function, okay? The Marshallian demand, right? And this is the inverse of Marshallian demand. And why I can write this? Remember, usually you can't write this directly, but when we assume that we are in the world, the income effect is very small. The Hessian demand is downward sloping, and the Marshallian demand also downward sloping. And when the downward sloping, you can write the inverse demand. So that is why you can, but you can also have that, and you maximize price, this case, and this Q have to be careful because implicitly you have to depend on price, right? It's a total cost function, right? Just to remind you, this comes from the C of the Q is coming from the cost minimization problem of the firm, okay? And this comes from the consumer maximization, right? Utility maximization, the Marshallian demand, right? And this is the inverse of Marshallian demand, okay? So everything comes actually from topic 1 and 2, right? Is that okay? And I guess I don't really need to do more, but because we already also covered that last class, it's just marginal revenue for marginal cost, okay? Just again, to interpret again, this is total cost function, increase in one single quantity, how much cost increase, right? And this is the marginal revenue. Just to interpret again what it is in marginal, if you sell one more unit, right, then everyone existing customer is paying P, right? So you increase one more unit that you would actually you should able to charge the same price if you extrapolate linearly, right? Or in case of it's perfect competition, right? So this is what you will see. But also, this is assuming that the quantity doesn't change, right? But now you assume now you consider a case where the quantity actually would change if you produce more, right? When you produce more, because downward sloping demand, right? The thing is like this, right? You have Q, this is P, right? And the question is, right? If you move your Q, right? Actually, P would change, right? This is the first one is assuming increase one more Q, the P doesn't change, right? But here is how it changed, right? Increase Q will change P, and if you increase, the total revenue goes down, right? If you decrease, then total revenue also will change accordingly, right? So that is the part that assuming price doesn't change. This is assuming the price will change, right? So that is the idea behind the marginal revenue, okay? And of course, in optimal, they must be the same because you really can't figure out, you can't really increase your profit, right? Because this is benefit, this is the cost, right? So just a very simple expression you write is price times this guy. You can write this CFT of inverse of your CFT demand, right? Because this is what we define, right? And turn out that we must have elastic demand. Okay, actually, you also learned that from the idea that, I mean, when you face a whole market, the optimal cannot be inelastic demand, right? Because when you have inelastic demand, what do you mean? You mean increase the price, right? The quantity response would be less than that, right? So you must, an equilibrium, if you're facing the whole market, you must increase the price such that it must be elastic, right? Otherwise, you will increase the price, right? Just to recap, if in elastic demand, what will you do if you're only single firm? You increase your price, you increase your profit, or increase your quantity. You reduce your quantity. I mean, the same thing, right? Why? Because this is the elasticity definition, right? This is what elasticity is, right? Percentage change in price over percentage change in quantity, right? If inelastic, you increase your price by 1%, the quantity drop less than 1%, the total revenue goes up, right? So that's why you would keep increasing your price, or in quantity, depends on what you want, because the same thing, right? So in that case, you will end up in the elastic region, okay? But of course, also you can prove it here because this is negative, right? So it must be bigger than, in terms of the magnitude, must be bigger than 1. So make this is positive, right? Because you have to negative 1, negative 1.2, then this guy is less than, more than negative 1, then this guy still remain positive. Okay. And that is the idea when you have monopoly. And here's another way. Usually you would see, actually we see then in the Cournot case is in the Cournot, in this particular case is, this is the markup, the numerator, and the whole fraction is the relative markup. Okay. And in the monopoly case is inverse to this elasticity of demand. Okay. So so in some sense, it is saying that elasticity, when you measure, is related to the markup. Okay, it's inverse to the markup. So this is important as you will see the Cournot. Okay. So any question? I think we just review what have been done. Yes. Why do we have this one? Oh, because you take minus. Okay, if so, what we have is this guy. Okay. The question is how we get this one. So okay. So the question is why I divided like this. Right here. And this is negative, so I just put. Is that okay? you can, if you don't like, you can put negative. You ignore the absolute value. Why I write this? Because textbook write in this way. And yeah, maybe I should write that. I don't know. Up to you. So the next question is about, next topic is about Cournot, okay? And probably you will say this is Cournot. If you learn it from the intermediate, this guy actually is 80, late 1800, I said 1870, I think 1870. It's way before the Marcel or Nash or those kind of people. So they have the Cournot, the guy who Leonard Cournot, I think. So he think about what happened when it's not perfect competition, okay, or how perfect competition comes about. Later you will see that in the Cournot model, people compete on quantity, and if you have many firms, in this model it goes to perfect competition, okay. So, so that's why you can try to see in a lot of IO literature, they try to say you model a perfect competition. You want to see if when n go to infinity and the entry barrier go to 0, do you see a perfect competition? Okay. Usually this is one of the exercise they would do, and they try to see if this do you restore the efficiency? Okay, that's usually you see a lot of paper doing that. Even you have a marketing people looking at search model. When you search friction, if the first friction goes to the 0, do you see perfect competition? So perfect competition we learned in the earlier is like a benchmark to see if you model in the right way, right? If the model behave well, you should see if you remove the constraint, you should get to perfect competition. Okay, so this is for people who know finance, right? And that is what we same as the M&M theorem in corporate finance, right? In corporate finance, M&M theorem said, I mean, for those who don't know, but we just say the value of the firm should be independent of the way it finance, right? It doesn't matter the firm's debt or using the equity should lead to the same outcome, because market take into account of those impact, right? And of course we know this false, right? But you try to see when you relax work assumption, there's a bunch of transformation to make the M&M theory whole, and then try to see if you remove the several assumption, what kind of thing you will see. And if you put it back, then you should able to see it back there, the original M&M theorem. Same idea here, okay? The basic benchmark is the perfect competition. And if you add little bit constraint, you should add a different model, right? And then if you remove them, you should get it back to the normal one, okay? So this is the same idea here. We add quantity competition and limit number of firm, and we try to, if you remove those, you should get back to the normal model, okay? If you can't get back the new model, then it's also a good point, because actually you will know what's going on. And in some cases, actually making infinity doesn't restore the efficiency, okay, in some model, okay. So, but this model is simple enough, so it restore the case, okay. So it's competition based on quantity, and it's useful when you consider the goods are homogeneous, okay, and firms have little price setting power. So crude oil is a good example. Actually, no firm is able to do it, right? And that is the reason why you see cartel, right? You see the OPEC is basically because of oil is relatively the same, right? Whether the oil come from Middle East, coming from North Sea is relatively similar. Of course, there's a difference if you know the detail, but relatively the same, right? And you look at go to the wet market, you look at vegetables, right, or fruit. Usually they have little price setting power, right? Because they are so homogeneous, right? But that is the reason why the Japanese fruit is so expensive, because they try to differentiate themselves, right? They make it, you have their own, you have their fruit there, then you feel very you feel very different, they have to differentiate themselves, right? So but when the product are not differentiated, no one is able to set a lot of different prices, right? So they are relative same, right? That's what happened when you go to the internet, right? And when you go to Taobao or Tmall, right? Look at product that with a brand, okay, and a lot of generic product. Basically, the price would be very similar, right? But if not, otherwise they can only set different price when the brand would make a difference. I mean, people in marketing know very well anyway. So in this model, we assume linear demand, constant marginal cost, and zero fixed cost. You can add it back. There shouldn't be an issue. Okay, the zero fixed cost has some interpretation later you will see, because of when you take to infinity, this guy would present or absent of this guy would change, right? Because if you have a huge fixed cost, then things will be different. Okay, but anyway, let's see. And so we have a very simple case. Is linear demand. Okay, it's just price equal to some constant A minus some constant C, the sum of all the product. Okay, here as you can see, you can add this together. Okay, that means that actually the consumer actually treat them the same, right? When you have this, it's just like you can imagine the market demand. The market demand in such a way that to the market, they are relatively the same. Okay, it may not be same for every single good for everyone, but the market as if they are the same. Okay, so that is what it is. Okay, and the J firms, and they only compete in quantity. We focus on price on the top of Bertrand. So assume the marginal cost. Okay, constant marginal cost is fixed for everyone. So this is what it is. Is the cost is some constant C. This is a constant. Okay, although the notation is a little bit not very good because it's a function, but this is also we use it as a constant. Okay, it's a non-zero constant. Okay, and here we have a constant marginal cost. You can easily imagine when we have contrasted. So then the result will be very similar. Actually, you can try that out if you want a contrasted one. Okay, so here we have a vector of quantities. It's just collecting all the firm. So profit of firm J. Okay, here is different from the monopoly, and also different from the perfect competition. Is that the profit is a function of the whole market Q. Okay, the vector of the supplies. Okay, the cost depend on yourself. There's no difference. Okay, but the profit, okay, this demand curve depend on everyone's supply. So that is how firms are related to each other, and that is actually the basis of game theory. Okay, your payoff depend on the other people's action. Okay, which we'll talk about that when we talk about game theory. But here's the main thing about why we have to talk about game theory is what your payoff doesn't only depend your own action, your choice of one, but also depend on other people's action. So that is the main thing about game theory. But we'll be more precise when we talk about game theory here. But here we just use it loosely, the idea of game theory. Okay, and we'll talk about equilibrium. But before that, do note this is a quadratic function of your own quantity. Okay, so now with this, then we need to define what's equilibrium. Okay, remember the equilibrium in the perfect competition is saying that the quantity demand equal to quantity supply, right? So the market demand, they cancel out, right? The cross, right? So what is equilibrium here? So this equilibrium concept is brought by Cournot. So that's why I say Cournot-Nash equilibrium. And later you see this generalized to any interaction. So that's why this idea actually generalized to general case we call Nash equilibrium. But the idea is very simple. Okay, in this model, firm only choose quantity. Okay, and what what they do is everyone's payoff depend on others people payoff. Okay, so the Cournot Nash equilibrium is the idea that if I said everyone produce at this quantity, okay, you guy number A produce this, guy number B produce this, okay, guy number C produce this, okay, everyone produce at that quantity. No one want to produce more, produce less. Then it's Cournot Nash. Okay, it's a very simple idea. Okay, we tell each one, this is what you're producing. Okay, and according to your profit function, okay, no one want to deviate unilaterally. Okay, so no one given holding other guys are constant. Look at each firm, would they want to deviate from that? Want to produce more or less? Okay, so let me repeat the statement more clearly. It's just like have to be formally just like for each firm, okay, keeping the other guy. I should have a star here, so this would be star. So keeping all other people quantity the same. Would I want to change? Okay, so in terms of terminology, there is called unilateral deviation. So given this quantity other people are doing, is the firm J want to do other things. Okay, do note that we just only check one guy changing, not multiple guy changing. Okay, and if you do more than multiple guy, there's a lot of solution for that. Okay, we just consider how one guy changed. Okay, you can, if you allow every guy changes, we will call strong equilibrium. If you allow certain kind of deviation that will be more complicated, will be correlation proof or correlated equilibrium, many things. We can talk about that in the game theory class. But in this model, we just focus on only single guy will change. Okay, and they do not consider very complicated deviation plan. But anyway, I hope this definition is very clear, very normal in this Cournot setting. Is you can easily, what is behind this equilibrium is you can observe how many others are producing. Okay, so you can monitor, right? So because you're saying that other people are not moving, you're not moving, it is in the sense that you can observe what other people are doing. You know what they have done, then you can decide whether you can see whether you're doing the right thing or not, right? In the case that you can observe, you can do secret price cut, you can produce more, then this is not appropriate. Okay, so this is only appropriate in the sense that the market is transparent enough so that every people producing and you will produce this much, the price is more stable, then you will see it's fine. Okay, so even if in the sense that because of Cournot in this model, okay, you will actually observe price, right? The market price, right? You will see the market in this model, right? You will see the market price. All right. So by observing the market price, if the market price exists, there's someone collecting the information for price for every store, then this kind of equilibrium would make sense. I hope I make it clear. So first is understanding this meaning of the definition of this definition of equilibrium is saying that a vector price, vector quantity, okay, no single firm will deviate. Okay, that's very simple mathematical idea. The second layer of understanding is under what condition this would be an appropriate equilibrium concept for application. Right? The first one, understand what it is, right? The second is understanding it is very simple, right? Just like I learn this quantity, no one want to deviate from that quantity if no one else is deviating. Okay, and when this concept would apply, right? It's a good appropriate equilibrium. Is the firm is able to observe Q, right? Can calculate and they will see it, right? And the easiest thing you can see from this model is their complete quantity, but they can see the market price, right? That's what they sell, right? If they see the market price is pretty much stable according to what you observe, then it's okay, right? If price is pretty much not really observable, then you are not, the Cournot may be a problematic thing, right? So that's why when you see the go to the wet market, right? The price is there, put there, you can actually see it, right? It's more like what we see in the Cournot idea, right? And although they compete in quantity, right? Because the price is still there, right? The price is still there. There's a price that clear the market, okay? And okay. And possibly you may wonder in the world who is competing in quantity, right? Or what probably in your mind, right? No one actually compete in quantity, right? You believe that firm is competing in price, right? For those who come from marketing, right? You will say, wait, who is going to compete in quantity, right? No one is competing in quantity, right? And there in the literature, there's many, in our literature, there's many explanations why firms are competing in quantity, okay? And one explanation is they are actually competing in production capacity. Okay, they would build their factory, how much product they can produce. Okay, and at the first round, and second round they compete in price. Okay, I think that's a very natural way, right? They compete in quant. The first, I mean, it's a two-stage game, but I will define game later. But the two-stage procedure, the firm first decide how many machines they're buying. Okay, and second stage they compete in price. Okay, and in that case that will be similar to Cournot, the outcome. So Cournot, you can say, is a reduced form of competition. It's some kind of back blocks they compete in quantity, but in fact it is in the background they're competing in price. Okay, and I would say Cournot, I mean, I use it to write linear demand, Cournot, marginal cost. I mean, this simple model, I think I write 4 papers already on this simple framework. Of course, I add something else, but even this framework is very useful. I mean, even this framework, I think more than 1,000 papers written in this simple Cournot framework. Of course, you add something else, but although it's simple, but when you add other things in the model, okay, simple framework actually is good. Otherwise, your model cannot be solved easily. Okay, so I hope I convince you what the Cournot Nash is and when they would be useful, right? Do note that you can observe what other people producing, right? And it's not that easy to see what is going on there, but say look at the oil market in the world, right? Every country is pumping the oil and the trading record is there. Okay, so that is easy to see what's going on there, right? Also in the wholesale market, how many goods or what's the price of being sold is also easy to observe, right? So those are good approximation for Cournot. Okay, now so how do you solve this? Okay, let me finish this with a break. So this is a Cournot Nash equilibrium, and we prove this is the result. The quantity you have is the A is the demand function. The A is the intercept of the demand. Okay, and C is the marginal cost. Okay, over B, which is the slope of the demand function. Okay, I think that is natural, and over number of firm plus 1. Okay, and that means that you have more firm. Each one will have less quantity, right? That's very natural. And similarly, the price is this function. Okay, and of course, if C goes up, P goes up, right? And look at this J over J plus 1, right? So if you increase J, P will be going down, right? And if you set J to infinity, okay, so what you happen will be very close to, yeah. Okay, but we will talk about the limiting case here. Okay. Now, I think this is, although I put the black one, I think you need to know, because we will talk about this in game theory. Okay. For the moment, probably you don't worry, but let's have a go over this before break. Okay, quickly. So first, how do you solve this model? Okay. And luckily, remember, in this model, okay, you don't worry about the equilibrium existence. It's because of this is quadratic in quantity. Okay, so it's a quadratic function. So when you maximize, then you don't have, with a leading coefficient, you should not worry about existence of equilibrium, because of the fact that how you solve the equilibrium. Okay, first you solve the maximization problem for each firm, right? That's what it means, right? So that's why how you do is, the first thing to do is to figure out what is the what we call in game theory later, this is called the best response function. What is the quantity that the firm would produce given what other people are producing? Okay, so best response is the idea that, okay, I don't know what other people are doing, okay, but assuming other people are doing this, what's going to do? Okay, and the function means given all other people's doing what I'm doing, okay, what's the best thing I do? So that is the best response, to maximize my profit. What is the optimal thing to do given what other people are doing? Okay, and because of this is quadratic as I meant, so the FOC is sufficient. Okay, so that means that for each firm, what's the best thing they do is given by one single FOC, right? And if we want a Cournot equilibrium, it means that there will be a vector of quantity. So we decide which firm to produce what, and this solves for all J equation. Okay, let me repeat the statement. If this is for each firm, okay, this is the best thing they can do, right? Because this is what the FOC of this, right? And if there exists a Cournot equilibrium, okay, this equilibrium will satisfy all the constraints, right? Because optimal should satisfy this constraint, right? Because FOC would be necessary, right? And also because in this case also sufficient anyway. But the Cournot will satisfy this constraint, and that actually means that it will be a n system of linear equation, and you easily see that this is not, it's going to be either you have no solution or unique solution, right? Or infinite many, right? But but if you have one solution, then yeah, it's easy to see that would be a unique one. Anyway, so how do you solve this one? There are many ways you can just directly solve it, right? But the easiest way is to do a shortcut. This guy is sum of the quantity. Okay, this Q. By the way, you can easily actually check that this is non-parallel. It's non-independent. So you will, the rank is full rank, because the leading coefficient for yourself is 2b, negative 2b. So that's why you will always have unique solution. But anyway, just forget about the math. But this spec is spec Q, okay? And you can rewrite this to this one, okay? Because this is Q, okay? And maybe I just wrote right down here, because I think it's important to know how to solve this one. Although it's tedious, I think it's good to write down here. Here I have A minus B of Qj minus B of big Q of C. Okay, this whole for J whole for 1 to J. I think it's good to go over this carefully, because I hope at least coming from this class, you know how to solve this model. I mean, otherwise, it's not very good, right? So how to solve this model? Usually I would do this. I just, instead of this, I write down the whole thing. Q2. Okay. So I have J equations, and I add them together. Okay. I add them. I add. Okay. Then there will be J of C on the right hand side because the J equation, each one is C. And here I have J of A. Okay. Here I have B, and I sum from J up to QJ, right? And here I have BQ the same, so it's J of BQ. Okay. But this guy is exactly Q. That's why I have that one. Yeah, I mean, there's many. I mean, you can just summation, of course. If you know how to do summation, you can just add summation to everything, then you're done, right? And once you have, but the reason I want to talk about this is because I often solve this so many times, so that's why it's good to know. And Q, and then just put Q the subject, and that's what you see. Okay. And once you have Q, now I put it back, then you solve the result. Okay. Once you have Q, then you put it back here because this is Q. Okay. And that's how I did, right? I just been jump a little one step ahead. So that's why you have A minus C over B. Is that okay? And the equilibrium price would be just A minus BQ, right? So that is what this number is, okay? And let's see the interpretation here, okay? Look at the markup, okay? Markup is A minus C over J plus 1, okay? And this markup is decreasing in J, okay? So as you have J go to infinity, right? Then this one go to 0. So that means that when J is go to infinity, P will be go to C. Okay? So that is price to the marginal cost, exactly the perfect competition you expect. Because in this model, there's no average cost, no fixed cost. So the marginal cost is exactly the AMC, right? This is the C, right? This the flag, the C is flat. Okay. So, and that means is same as perfect competition. Okay. So that is the nice thing about the model, right? So everything is, although they compete in quantity, but at the end you get back the perfect competition. Okay. I hope that convince you that is a usual way when we try to learn the property of certain competition, right? When you marketing or finance, probably not finance, marketing, when you try to build up a model of a perfect competition, then you have certain way the firm behave and certain way the consumer behave. Okay, you make the way they behave, then you want to see if the many firm, do you go back to perfect competition? You might or might not, depends on the way you model the imperfectness. But you better have the way to explain why your model doesn't reduce to perfect competition. Okay, if you don't. If you reduce to normal one, this is the way you're going to explain, right? But if you don't, then you explain to people why your model do not behave in this way. That can be a strong point, right? It may not be the weak point. It can be explained what the intuition behind the model. Okay, so that's a break, and then after the break we'll talk about Bertrand, and very quickly, and then we'll do monopolistic, and then we'll do general equilibrium. Okay, so we know it's an unfortunate fact, right? It's like when you have more firm, that there's no more markup. So that's why it has been suggested many times for economics, we should restrict the entry of Ph.D. like the B school, so that keep the markup there. And that's what expect the license or the professional bodies like restrict entry, right? So these days, the medical doctors from China can actually, or around the world actually can enter in Hong Kong before no one can actually enter Hong Kong. They just restrict only you graduate from Hong Kong, you can do being a doctor in Hong Kong, not even in US, not even UK, everywhere. But now they have to open, and you can imagine that the markup they have is just like will go down, right? So I mean, yeah. So next is price competition. So we focus on a special case of so first we define the bold P is the price vector. So we focus on the case that from the perspective of consumer, goods are substitute, perfect substitute. Okay, it doesn't really matter the good is from firm 1 or firm 2. Okay, that is a very special case. Okay, and although it's very special, it is not that restrictive in the sense that consumer cannot perceive the difference. Right? Look at Taobao and Temu or the e-commerce platform, and they're retailers, right? Many of them are retailers, not the producer, right? Retailer getting good from the manufacturer, right? And in that case, they are very similar, right? Because you get an iPhone from Apple, right? And selling the product to the consumer, it doesn't really matter which reseller you're getting from, right? Whether you get from a store A and store B and store C, they're the same iPhone. So for them, it's perfect substitute, right? Or for generic thing, right? Or in China, there are so many improper or informal factory, 山寨厂, right? In that case, it's a very similar thing, right? So the same product, okay? So what does that mean? In that case, I don't prove it, but actually you can formalize it, but you can easily see if you try to buy this, right? Your demand function is actually not continuous, right? Because all the good is same to you. What are you going to buy? You only spend all the money on the cheapest one, right? So that means that the cheapest one with the market price. I mean, only the relevant thing is the cheapest one, right? Anything that more than the cheapest one will not get bought, right? So do note that this is a very special case, is perfect substitutes, right? Means to tell you like this, okay? Usually you don't see this in your book, but this is what happened actually behind the model, okay? And usually you will see the textbook would define like this. Your demand function, okay, would be this very complicated form, but this is what it is, right? The demand function is like for firm J, is that if your price is lower than the lowest of all the other, you're facing the whole market. Okay. So what's different between this one and this one? Okay. This one doesn't tell you the quantity, right? Here I tell you what's the demand, right? Because everyone would go to you, right? If you're lowest of all, so this is lowest price besides you, so all other firms' price lower than that, you face the whole market. And this is demand function, right? This based on the market demand at this price, this is the case. Okay. And if your price is higher than the minimum of all, then you get 0. Right? So these two are very natural. I don't think you need explanation. This one is the most technical one. Okay. And although it's very technical, but also very important, actually the equilibrium appears here. Okay. This one said if your price is same as all the minimum of others, you will be sharing the market equally with others, depending on how many people are actually lowest. Okay, the denominator is how many firms they're charging the lowest price. you are equally splitting among them. Okay, and we make the assumption that the equal split, it need not be, right? But equal, I think, is the most natural way to do it. Okay, and why not equal? Maybe some firm historically more favorable, even the same price, you likely go to that more. It's possible, but the easiest thing is to assume equal splitting. Okay, so the equal splitting is assumption here. Okay, do note that we make assumption on equal splitting, but I think it's very natural anyway. Okay, but as I said, it need not be the case. You can have some assumption. One firm is like have better brand name or historically better, then you can do that. Okay, is that clear how the demand function looks? Why we have this demand function? Okay, and this is very important to write down that very clearly. Okay, let's differentiate what we learn in the intermediate class or what we do research, right? We have to, I mean, at least in economic research, we have to specify everything very clearly. Okay, in some B school journal, they would not do that. Sometimes they just skip, and that actually leaves some gap to the reader. When I read those papers, actually I have questioned what they are meaning. Actually, I mean, they don't define equilibrium properly. They don't define things properly. They maybe just give you this and this. They don't define the middle. Okay, so sometimes you just, I mean, sometimes you may not need to write it, but actually in your mind should be very careful. And if you skip those, actually may be the source of issue, especially when talking about equilibrium. Certain corner case, in this case, actually, later you will see, this definition is very crucial. Okay, but anyway, here's what I said, right? The lowest price will get the whole market. They will splitting the tie. If you are not lowest, then you get nothing. Okay. So I assume constant marginal cost. Okay, and everyone the same. Okay, to make the case more easily. Okay, and so this is the profit function. Okay, so there's no difference, but you just minus the cost. Okay, this is the margin. This is a markup times the quantity, right? So the only difference is I have the markup here. Okay, compared to this one, right? I just time the markup. Okay, so now what is the equilibrium? Okay, so actually same as the Bertrand equilibrium is actually the same the Cournot equilibrium idea. Okay, in this model, every firm choose prices. Okay, remember the Cournot equilibrium is I dictate what each firm should put the quantity, and under this case, no firm want to deviate from that quantity if other people are not deviating, not changing. Here the same, instead of price, quantity I have price. I would say this is the price for each firm. Okay, and for each firm I will check if other people are not changing. As what I said, they follow up my instruction. Do they want to deviate by themselves? Okay, so that's the idea. You dictate the price for each firm and ask, is it each one is doing the best they have been doing? Okay, then it's equilibrium. Okay, and do remember that we didn't say this is a unit. We didn't say what happened if this price deviate, everyone deviate from this one, what would happen? No, we didn't say about that. Just like no one would deviate from that by themselves. Okay, not say if everyone deviate, do you have that? I don't say it. What happened if everyone don't follow what I'm doing? Would that also another equilibrium? No, I didn't say that. Okay. So, and in this model, okay, did I prove it? No, I didn't prove it. Okay, but let me argue it. In this, what is the equilibrium outcome? Okay, the proof is here. The proof with the equilibrium price P star is actually C. Okay, what I claim is everyone will charge C is an equilibrium, and actually can prove that it's a unique equilibrium. Okay, let's try to prove it. Why equilibrium is this one? Okay, the profit. Okay, now first I argue why everyone charges C the equilibrium. Okay, if your firm J, right? If every firm is charging C, what happened to your profit function? If everyone charges C, okay, the minimum of other firm is charging C here, the minimum C. Okay, And if you charge lower than C, actually you're making loss, right? Because you charge price lower than C, you're making loss, then it's negative profit. Then you would not charge lower than C, right? You rather go to the 0, right? Because negative profit. Okay, this is 0. And if you go to here, look at this. Other people charge C, you charge C as well. And you charge C, you also have to say 0 profit. Okay. So actually you're indifferent between charging a C or charging more than C. Okay, charging below C, you make a loss, right? So anything that C or above have the same. Okay, so same to you, don't deviate, then it's equilibrium. Let me repeat the argument here. Okay, first I argue that everyone charge C is an equilibrium. What's the case? If everyone charge C, to me, I charge less than C, I make loss. I'm not doing that, right? I'm charging more than C, I also get 0. C is also 0. So I don't want to deviate from that. Okay, it's optimal thing to do, right? So that's equilibrium. Okay, the thing probably you want to argue, which more sophisticated, is this is the only possible equilibrium. Okay, do we have an equilibrium? Actually, we'll argue later. Is do we have equilibrium? Someone charge other than C. Is it possible that price is above C is possible? No, it's not possible. The reason is being that suppose the minimum of this is not C, it's higher than C. Okay. Okay, suppose. Okay. Okay, there are several ways I can argue, but I think it's good to talk about this here. Is what we have said is already the P star is C, 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 C. It's an equilibrium. Okay. I'm trying to argue that I think the first one is very simple, is you shouldn't have the equilibrium price more than C. Sorry. You shouldn't have an equilibrium price that is less than C. This is the minimum of the P, right? Okay. So I will try to argue because everyone go to the minimum price, right? So this is the market price relevant. So you shouldn't have this, right? Because if this, then every single firm, the lowest price firm will actually want to charge C or above to make sure that he don't make any losses. Or otherwise making losses, so this cannot be happening. Right? Because if this is happening, firm are making losses, they rather not doing the business, right? So that is simple. The next question is, this is impossible as well. The reason is being that suppose there I dictate that there's some prices, okay, may not be equal, but then the minimum is bigger than C. Okay, that means that some of the firm is charging the price more than C, right? And in that case, if you are one of the firm, okay, that is not belong to the minimum, okay, that you are making 0 profit, right? If you are not the guy minimum, you're making 0 profit, okay? You can put any price in between, then you can make positive profit, right? Then you break the equilibrium. Okay, this is the first thing. I'm not done yet, okay? The first thing, look at if there's someone who is not charging P star, okay, then he must be charging more than P star, right? So consider the case where firm J, PJ is more than P star, okay? Then what he will do, he's making 0 profit because he's not selling anything, right? In that case, he would deviate to something. He would like to charge, say, anything in between, maybe P star minus C/2, whatever. Maybe P plus T, somewhere in the middle. Or actually, you can, in general, right? You can put anything between C and P star, right? Then you can make some profit, right? He will deviate. Okay. See the argument. First argument is if there's some firm that is charging, is not making any profit, right? It's not lowest price, not making profit, and they can charge anything in between. He can make some profit, right? Because the whole market go to him, right? The first argument, the first one. The second one, a little bit more elaborate here, is if that particular guy is actually one of the guy who is making profit, right? Because in that case, he's making profit, okay? And in that case, it must be the case that everyone is charging the lowest, everyone's on the same price, right? I mean, if this is not applying, it must be this applied to everyone, right? And he's making this positive profit, right? But why he would be deviating, right? Because before he's enjoying this profit, and let's say Q, and everyone is, because it must be, if this doesn't apply, it must be everyone is charging the same price. This is his profit, right? And we try to argue that it's P star, okay? We're going to argue that we can always find a P hat, okay, such this P hat is higher than this one, because he will be, and P hat is less than okay. Why this is feasible is because in this case, J is more than equal to 2, right? Because before you must be sharing with others, right? In that case, I just lower a little bit, right? You can just, the simplest case you can say is equal to the P hat, it's just minus epsilon. Epsilon is as small as you want. Just charge slightly below the proposed price, okay? Then you will get the whole market. Compare you splitting with others. Oh, sorry. Let's say. Q of P. Okay. Is that clear? Okay. Now, this is beyond what we're doing, but we'll be doing this in the game theory class. I'll just give you an idea why we're doing this. I mean, it's more than what we have proposed, but I think I confirm, I mean, the main thing you need to remember is at least this is equilibrium, okay? And this is what you need to know, but I'm trying to show you that this is the only equilibrium, okay? In the sense that we said that doesn't exist the price below the marginal cost, and I argue that if it's more than that, there's some people who will not be happy. Okay, if you are not one of the one who is selling, then you would be captured the whole market, you would deviate. Or even though you are the guy who is splitting the market, you will still deviate, because getting a slightly lower price but the whole market is better than sharing with others. Okay, that is the idea, and that rely on your demand is continuous, right? Because your demand is continuous downward sloping demand, so this is possible. Okay. Okay. Yes. Yeah, as long as more than equal to 2 years. Yeah, it is. Yeah, that's a good question. Yeah, there's nothing related to the number of firm. Yes. So the result is independent of the firm. So that is actually a very good question about why this thing would hold even if 2 firms. Okay, that is actually what we call the famous in IO literature, they call Bertrand paradox, right? Why? What on the earth in this world you expect when two firms are competing, they compete to the case they charge marginal cost, right? There's no reason to expect this would happen, right? And actually, that's why in the IO literature in the early days, they focus on trying to add things in the model such that you don't have marginal cost pricing, right? Because in the real world, probably marketing people would disagree, right? No one actually charging marginal cost, right? And there are many things. You look at the IO textbook, they will see there are many ways to do it. First is there we call capacity constraint. Okay, no one is able to supply to the whole market, right? This model, the main you can see all one of the key things is these two argument is one firm is able to supply the whole market, right? And actually this fails in the real world, right? So even Tesla is very good. The production capacity is light limit, right? There's a physical limit or engineering limit on how much you can produce, right? At least for a given period of time. Okay. In that case, you will not go to the marginal cost, right? Another, there will be many issues here, but I'm not going to elaborate. But if you want to know, they can check out the textbook of the IO. They would spend huge amount of passage. Basically, the whole literature of many part of IO is basically focused on why this thing would be, how to make this thing wrong. Okay, how to make this thing wrong. It's called the Bertrand paradox. I hope I answered your question. And because this immediately go to perfect competition, right? So, and actually that's the reason why a lot of paper would actually, this is a very interesting thing is you have downward sloping demand, right? Why the firm competing in price and competing in quantity, they're different, right? And indeed, there are a lot of paper tells you that, I mean, there's a fundamental thing you need to know is price competition and quantity competition is indeed very different. And that papers in the good old days is someone look at this problem using price competition, say, and will derive certain result. Okay, and other guy will come in and say, okay, let's do quantity competition and derive other result. Okay, they publish. And of course, this is already the old days. No one would able to publish this anymore. I mean, some people can do it, but probably people will ask you to do both. I mean, because the result really depends on whether you're price competition and quantity competition. So we crucially depends. Yeah, they would all separate. The reason why you can see in this model, probably you will talk about the term later, is in the price competition model, firm's strategy is what we call complement. Because if my price higher, your price ought to be lower. So higher, right? So we want to move in the same direction. I say higher price, we want to say higher price. Okay? But in quantity competition, it's exactly opposite. If you produce more, actually one produce less. So that turned out to be a crucial difference between these two objects. But anyway, that is game theory idea. Okay, but yeah, it's a very complicated thing. Game theory is reserved the game theory, but the last one is before the Cournot and Bertrand is homogeneous, we focus on heterogeneous. Okay, and as I said, this is the easiest heterogeneous model. And probably if you do empirical, you want to look at discrete choice model or other type of model. But this is already, I think, will serve a lot of, if you do empirical paper, that would, I think, it serve most purpose. Okay, unless you have a very specific in your mind, because it's generic enough, you can see. So you see this, each firm face a downward sloping demand. Okay, and this from monopoly, this depend on price of all other firm. Okay, in monopoly, you just depend on your own price. But now your quantity demand depend on price of other firm. So this is how your payoff depends on other firm compared to monopoly. Okay, and the firm cost function only depend on yourself. Okay, so and of course you can imagine that this need not be the case, right? Because if I produce just like the airline company, right? Now I produce more, I need to have more pilot, more food, more thing, more oil than other firm. But I think no one actually, I mean, at least I see the model, no one actually connect this thing. So most paper I read is just this independent, the only dependency come from the demand side, but not the input. Okay. But you can imagine that, I mean, when you write paper, it's possible this is important in your industry. In that case, that's fine. But you focus on a small industry, right? You can always, if your small industry is small, then you affect the impact on the whole economy is small. So this is fine. Okay, usually this is okay. But if imagine your industry is very big, then this thing can be a problem, right? Just like when Apple increases production, then it actually affects everything in the industry. But anyway, this is the profit maximization problem, right? So this is very similar to the Cournot, right? Except now we choose the price. Okay, so you can see sometimes people call this is a generalized Bertrand. Okay, and the one we have is a Cournot. This is generalized Bertrand. Okay, and what we see here is what's the equilibrium definition? Same before. Okay, same as the Cournot case or the Bertrand is they choose price. So what I meant is equilibrium will be a list of price, okay, price for each firm. And we ask each firm, do you want to deviate? Okay, I ask each one, if no one deviate, then it's equilibrium. Okay, someone propose a price, no one want to deviate, then it's that. Okay, so you will see when you differentiate, maybe I should do it because probably you think I'm skipping some step. I just do one step here. How do you do this one? So the price is just this guy. So I want to maximize this. Right. Choosing PJ. Okay. So how I get this? Okay. You differentiate PJ, you use the product rule. Right. So you differentiate this first and you get QJ, right? Under bar means the both. Plus PJ, and you differentiate the second guy. Right? And this one is just Y, right? It just differentiate C. I use the chain rule. That's how you get this one. Okay, I hope this is clear. I mean, you should be clear about this, but otherwise, have to be careful. Okay. So this one looks like very different from when you have quantity, right? But the fact that we use this inverse function theorem. The inverse function theorem. So dx dy is inverse of dy dx. This is this. If you and that is nothing but just you flip it. Okay. So this you multiply you multiply this. Anyway, you divide this, you will have this guy. So this is that clear? Okay. So, but this is just marginal cost. This is the marginal revenue. Okay. And in this particular context, actually it doesn't really matter when you look at the price and look at the quantity, because it's the same thing, right? If you maximize with respect to Q, actually you get this one, right? The reason is being that you're facing a downward sloping demand, right? So each firm is facing a downward sloping demand. So okay. So, and this is the short run equilibrium. Here you can see, because I didn't give the P was Q, that's what it is. Okay, that's the best thing you can do. So the equilibrium is just the solution to this one. Okay, this is implicit form. So not very happy, but this is what the outcome you have. And the problem is, with this, do you have equilibrium? Right, because this thing can be polynomial or not polynomial, but it can be very crazy shape. This can be very crazy shape, right? So you may not have equilibrium, you may have a solution, right? Because if a system of equation need not have solution if non-linear, right? It can have more than one solution, okay? So the solution is not guaranteed. Of course, that paper tell you what is guaranteed, okay? But I hope but you will see when the equilibrium will exist. But if you don't put any restriction, then this is what the best you can get. Okay, just get MRU and MC. That's it. And if you consider a entry, okay, free entry, every firm making the same profit, then your addition thing is revenue to cost. So you have another condition. Okay, so that's what you do here is you endogenize J. Okay, so remember here already we have equilibrium, right? Then the question here is J is also part of the equilibrium when you're free entry, because firm can enter. So I didn't make it explicit, but here we need J to be the part of the equilibrium. So the equilibrium consists of price for each firm, and also, of course, J, because we have supposed to be talking about free entry. Okay, is that okay? So this pin down, this condition, right? The short run for each J was to be this, and this with J pin down the J. Is that clear? Any question? That's a break, and then we talk about general equilibrium. Okay, I hope that I convinced you that you can use this for application. If you try to at home, if you want, you can make it a linear demand, constant cost. You can easily see how the model being solved. Okay. So general equilibrium, okay. And as I said, I mean, this is a huge topic, but I don't think it's important for most of you except those people who do finance. So I just try to be very quick. I do apologize because this is a very important topic, and I have told you that my advisor's advisor is De Brue, who is the founding father of this literature. So anyway, but I'm not doing this, okay? So it's a kind of a false claim I'm the descendant of this huge thing, but I should do more emphasis on this. But anyway, my advisor is still doing this, some of the paper, I mean, but I'm not doing anything anymore. So I don't claim expertise on this. But the idea is so important. I think this is one of the reason why economists exist, right? Because economists justify capitalism, right? We explain why capitalism is good through this kind of model, and we are living in a capitalist society, more or less, right? Probably except North Korea and Cuba, right? And most of places basically use the market to solve the allocation problem. I mean, even I think Korea also, some of the places also use money. So we justify the existence of this society so that B school, right? Everyone is in B school, so this is what it is. So so what I'm going to do is trying to consider a case where general equilibrium means that we have everything in the model is endogenous. Okay, here in the model here is say the cost function. Okay, you remember the cost function is not only depend on the quantity but also depend on input prices, right? We omit them here, but we want to general equilibrium is trying to say, okay, what happens if you allow those price to be determined simultaneously? Okay, so this comes from the actually general equilibrium comes from the in the partial equilibrium actually comes out in the Marshallian way, right? In the 1920s, 1910, those early 90s, and after that, people want to know, okay, is going to be the equilibrium going to be true for every single market, right? Just graphically, it means this, right? Remember, we have demand and supply, right, for a single market, right? And this is string drawn holding all other market the same, right? And you want to ask a question is, if I have another market, right, P2, right, and we know that depending there was substitute or complement, right, change in one market affect the other one, right? So asking whether is there any case that there will be an equilibrium so that every market, the price and quantity will be equilibrium, right? Just the same, actually the same idea with here, right? We consider the case, we have this equilibrium in one market, right? Suppose we consider many markets. At the same time, do we have equilibrium? Okay, so that is the question. All the market, do we have equilibrium? Okay. Of course, the question is, yes, we can prove it under various conditions. Okay, and at the end, we try to argue that there's some issue here, and one of the main thing is in this literature actually almost dies out in 70s is because of the rise of information economics. Okay, when actually the information is a big thing, okay, and the market fails, like what you learn in the undergrad or Lemon's market, basically kills the whole literature. Okay, when the information asymmetric, then the market disappears, or it's very difficult to find equilibrium. Or from the finance literature, what we learn is not everything is traded, or it's called incomplete market, right? Not just like not every single asset is traded in the market, right? In that case, that equilibrium existence efficiency is an issue, okay? But focus on the general thing. In general, the general equilibrium is a good approximation, right? And we try to prove it, okay? And first we prove the existence, okay? And then we try to tell the efficiency, okay? And we try to tell core stability there. And then we'll talk about something it's not covered in our class, okay? And those who learn the finance, then probably will find it very trivial. I think they cover it in the everything in the first class, okay? So very simple idea. Do note that because we talk about many market, okay, and many consumer, many firms, then this type of model will be notation will be very heavy, okay, because you have to have ways to tell so many complicated objects, okay. So the first thing we do is to remove complexity by taking away the firm, okay. So we just focus on consumer. There's no firm in this model, and we see without firm, do we have equilibrium, and then we add the firm back, okay. But for our class, we don't talk about firm because actually the mathematics actually is not more complicated with firm or without firm, okay. And at least for the basic one, okay. So we just focus on the things without firm. With firm, then it will be much more complicated, okay. So we have M customer here, N consumer, and we denote the consumer I consumption on good K is the subscript is the good, and the superscript is the agent, okay. So that is I think it's a little bit tedious, but I mean I just follow the text, the book, the Randy book they use, so that's why notation is a little bit unnatural, but I don't know whether you like it or not, but this is the one we use. And consumption bundle for I is a X, then now it's I compared to topic one, right? Because they are I consumer. Okay. And we assume consumer has preference like this and represent by this utility. Okay. And when I write this already automatically in your mind, you should know with some assumption on the preference, right? It must be complete, transitive, continuous, and at least you learn is monotone, right? Then you get this one, right? This is existence of utility has assumption on the preference, okay? And actually most of the proof actually don't rely on this existence of utility, but we just make our life easier to focus on utility, okay? You can actually prove everything without utility, but we just focus on utility. And here we don't consider production, okay? So that's what happened is you can consider everyone as endowment, okay? That someone give something, left you something. That no one is working in this model. So that's everything you can imagine is a island with many trees, okay? Apple go on the tree, just go to get it, okay? And it's already given to you, okay? Is that okay? So each one have endowment angle, and they can be endowment can be 0. That's fine. So you don't have to endow. There's no restriction on the endowment. Is that okay? So in this simple model, we can describe in usually we call exchange economy is by telling that the n. Sorry, I use the notation I here. So I think you should change this to I as well. Sorry, it should be I. Okay, this is I, this will be I. Okay, so there'll be I agents. Okay, and each agent has a preference. Okay, and there's an endowment to them. This is a whole description of the whole economy. Okay, I tell you the NI guidance society, what are the preference, and what are their endowment, and that's it. Okay, what is determinant system is everyone has some goods, right? At the end, they want to trade. Okay, and we will decide the price. such that they are, after changing, they are happy with under that price. Okay, there's a certain price such that they will not be engaged in further trading. Okay, so we will call the allocation is and notation. Sorry, this will be 1 from 1 up to I. So this will be 1. Okay, x1. So that will be for each one. I will tell them what should they consume. Okay, and the allocation is the outcome of this exchange economy, right? They have the bundle, right? And the main question is, what kind of outcome we will get? Okay, this is the main thing of this model. Okay, and the first thing is that feasible allocation. We focus on what is feasible, right? Feasible means that so this is the vector notation. So it means that for each good J, okay, sum of FE1s, okay, some allocation is less than FE1's sum of the FE1's endowment. Okay, I probably should write down here because probably I should use, I don't know whether I should use vector notation here. I mean, you may overlook it. So actually, it means the following. What I want is, I want for good one guy, plus good one for 2 guy, up to x1 I less than E good 1 1. Okay, and I've n good, so there's x and 1, x and 2, x and I less than okay, and this is, you can write this as summation, right, of x j I from 1 up to n, and summation of ej I 1 to n for j, all right, because you have n different good here, all right, and for this is exactly this vector notation. Okay, so someone asked me in the break why we do so many complicated notation, vector and thing, because you see, writing this is much easier than writing the whole thing, right? I mean, otherwise our slide will explode if every time I don't do the vector notation. Okay, that's why you read the Mask, Colette, Wilson, Green, every time they use vector. Otherwise, the book is already very thick. Now, if you don't vector notation, then we like this, right? Cannot. Okay. And here we define what is feasible, right? Is f of E depend on E. Endowment is all the allocations such that are less than what is available, right? So this is what is just like you cannot allocate more than what you have. Okay. Very simple. Although it just like look a little bit more trickier when you look at the notation. Okay. But I think it's good to let you train yourself not to be afraid of seeing this notation, because you have to read it because you are being a PhD student, right? You start to not to be scared by math notation. At least you try to understand what's going on there. As now is that you're in a classroom, right? You can ask your teacher. That's me. But I mean, I will not be your advisor, so you don't leave a bad impression. You just ask me, okay? But you should be more careful when you try to ask your advisor, right? If you keep asking question that is too elementary, then it doesn't. Your letter later they write to you when you go to find a job market, then not be good, right? So here you can ask me more, but you should be more careful when you deal with your advisor, right? Later. In general, maybe some advisor is very open, but I don't know. Anyway, assumption of utility, as I just said, because utility exists, and when you have continuous increasing, okay. And here we also assume strictly quasi-concave, The reason is being that if we have this, we will have a solution, unique solution to the utility maximization problem. Right? Remember the utility, when utility is like this, right? Then it's like indifference curve like this. Right? Then you have a unique solution here. Right? So that's why we assume that. And here we assume f a price taker. Okay? So you maximize utility subject to the constraint. So the only difference between topic 1 and here is your income is not a constant. So your income depends on price as well. So that's the main thing. Okay. If your income is a fixed, then we know everything already. Okay. The only difference is the price is not, the income is not fixed. Okay. The income depends on the price. Okay. And do note that the main thing about this model is to try to figure out what is the equilibrium price, what's the price, such that everyone's happy with what they got. Right? We will be more specific later, but this is the goal of what we are doing. Okay. And as I have argued, under our assumption on the utility or the preference, we will have a unique solution. Okay, because P is exogenous, right? So that's why this guy, when the P taken exogenous, this is same as a number, right? EI is exogenous, right? P is exogenous. So P times EI is just income, a number, right? The dot here means dot product. I think it's okay. Everyone know dot product, right? Just like P1 times X1 plus P2 times X2. This is just, I just write down. In case, because I can't assume, because you guys are a little bit shy, so no one say anything. So I'm not sure whether this is okay. So this is just summation of I from 1 to n. Okay. Yes. And to the. Okay. And okay. Make sure I should add I here. Okay. So this J. Okay. Is that okay? Hmm? No. When you have dot product, then vector, they must be 1 by 1. Okay, you either you write this, but you dot, that means that you don't have to worry about it. Very good question. I mean, it's always, I mean, by definition, always a column vector. But if you either rewrite this one or you write this one, because you have to transform the same thing. But dot means this. That means dot product. Very good question. Okay. I mean, for those who learn econometrics, they will not be happy with what I'm writing because they have to be very careful writing this. But because we are not handling the matrix, so that's why it's always vector in our case. So that's why not easy. Okay. So here, this is a very important concept. It's called excess demand. Okay. Excess demand is, the definition is very simple. Is what is the X? Remember what's X? Is the allocation. Okay, allocation is the sorry, this X is the Marshallian demand. Okay, this is a demand. The Marshallian demand minus the your endowment. Okay, and do note that this apply for every good. Okay, look at good K. Okay, look at all the demand from each guy minus total endowment on this good K. Okay. So this is excess demand is for each good. Okay. The difference between what has been demanded and what is available. Okay. And for this system is what we consider is probably the deficit of the system, right? If this system, the Z, okay, if the Z is negative or zero, this system usually we call it stable, right? Because no one more than what it is, right? And if this system is, if Z is positive, then actually people want more than what they do. It's not very stable, okay? So indeed, okay, look at the following, okay? Under optimization of everyone, profit maximization, sorry, utility maximization. So what you get is we can prove the following thing, okay? Is this excess demand function, okay? It's continuous in P, and also it's homogeneous in degree 0 in P. Third is Wawa's law, okay? So the Wawa's law is very important, okay? But I first said the first one. The proof of first one is very simple. Because your demand is continuous in P, okay? I didn't say it in our topic 1, but you can imagine that. Look at the problem here. You have indifference curve. You have the price, right? If you slightly change the price, okay, you should expect your demand also change slightly, right? There's no sudden jump in the demand, right? Then your demand, the X, is continuous in the price, right? Although we don't prove it, but I think it's very natural. You can see that. That's why when this demand is continuous in P, so this is also continuous in P because this is independent of P. Okay, we didn't prove it, but I think it's natural. You can see because when the preference is continuous, your utility function is continuous, so everything transformed to here. Is that okay? I mean, we didn't prove it, but I just try to convince you this is true. When the pricing a little bit, your demand doesn't change a lot, right? Suppose the price of, I don't know, the food store in the canteen, right, just changed from $40 to $40.10. Okay, your demand will just change a little bit. You will not say that suddenly say, okay, you increase in 10 cents. I'm not going to that store anymore. Right? It's not that radical. Okay, slight change in price would only lead to a slight change in the Marshallian demand. If this is true, which is I think is true because your preference is continuous. Okay, and you've assumed that, then your excess demand is continuous. Okay, and second one, homogeneous in P, is very easy to see. This is coming from the Marshallian demand, because you increase every price double, and demand also double. So nothing changes. It's coming from Marshallian demand, right? If you let's see the, I don't know whether I can convince you this. It's coming from the it's XD0 from, I think we have here. Yeah, it's coming from that. If you double your price and double your income, it's no change. Okay. So because you increase your price, you also increase your endowment. Okay, so everything the same. Last one, I think the most important is Wawa's law. Okay, which essentially said the following, right? The value of excess demand must be 0. Right? Because the price times this, right? The dot means P1 times Z1 plus P2 times Z2, so on and so forth, is 0. So that means that if there's an excess in the system, okay, you should see there's no value. Okay, that's what the Wawa's law said. I mean, of course, we prove it, but we try to prove it. I mean, but that is what it means. Okay. And actually, I also explained during the break, right? Why I keep talking about explaining the equation is because I don't put it in the notes, but when you write your paper, when you try to do theory, I mean, or you read the paper, then actually once you write an equation, you have to spend a lot of page to explain what is going on. So what I'm doing is try to give you the idea behind why they are right and what they mean. Okay. And how to prove it? It's not complicated. Just some math looks complicated. Okay, but the idea is very simple. Let me explain to you. So the main thing is the key thing is the reverse summation sign. Okay, so the simple thing is the first line is because your preference is monotone. So the Wawa's law holds, means that everyone will spend all the money they have. Okay, that means that your budget constraint would hold. Okay, and this something you don't see? Can you see why the first one is correct? The first one is correct is because of this, right? Is your P dot X should be same as P dot T, budget constraint, total, and you subtract, then you have. So this is what this is. Can you see that? I mean, is that okay? So just like this is the right difference, and you hold it, sum it for all the goods, right? Now, and then what we're going to do is this is holding true for every consumer. So every consumer, so you just add from consumer 1 to consumer n, right? This is still 0, right? Summation on. And now what's the trick here is because everything is finite, right? When the finite summation, you can always swap. So that is the main key here. Okay. Now, because it's finite, you can just swap summation sign. Okay, just swap. And the price, right, is in matter of K, you can take it out. Okay. And this guy is what we call excess demand. Okay, so that's why 0. So that is the Wawa's law. Okay. The reason why it is 0 is being that in general means because everything is worthy, right? If there's something left over, it can't be worth something. That's the main idea, right? Because this is what it means is someone want more than that, right? Someone want more than what we have, okay? And it must be the case that it cannot be worthy, right? Otherwise, I mean, the system then it's not maximizing, okay? Because someone is selling that thing, right? Someone is going to sell that thing, so it must be 0. But anyway, this comes from the idea that everyone must spend all the resources, okay? And here, what the implication of this was called the Wawa's law. Here, the other term Wawa's law is if you try to rewrite that, that means that the sum of the value of the excess demand must be 0. Okay, and that's an interesting consequence is if all market but one is perfectly clear. When it's clear, that means excess demand is 0. Okay, the last one also clear. Okay, so that is one important law. They said if n-1 clear, the other one will clear. Okay, and that is it. I mean, there's nothing deep here, but but it just say one interesting thing. Okay. Now we're trying to, same as before, we try to argue what is equilibrium in this system. Okay. The equilibrium in the system, we argue that the excess demand is non-positive. Okay. Can be zero, of course, yes, but it can be negative. Okay. Because we can have more endowment than we need, right? Just like air, right? Air is free, right? So it's okay because satisfied by Laplace law, right? P times excess demand is fine. So that allow. So in general, we allow negative. Okay. So that is why this equilibrium. Okay. Because you just say no one want more than we need. Okay, that's the price. Okay, there's no shortage. Okay, so Laplacian equilibrium means at this price there exists no shortage. Okay, price adjust such that there's no shortage. It's okay to excess demand. That's fine. Okay, so it's okay to excess supply. Okay, that's fine. We don't not allow excess demand. Okay, so this is the price that clear the market. Okay, that is what it means, right? So now we have the first theorem. Okay, the important theorem is if we have continuous short monotonic quasi-concave, okay, and endowment are positive, okay, for each good, okay, not for each agent, just each good only, okay, and in that case there will be a price such that the excess demand is non-positive. Okay, so that means that the excess price such that everyone would be happy at that price. No one would want more than that. Okay, someone given the price, they can trade, and the trade would end sometime. Okay, and ended at the price such that that you can't fund excess the deficit. Okay, there's no excess demand. No one is unhappy given the price. Okay. So how to prove it? Is very complicated. Okay, I used to cover this, but I figure out that it's probably not good to cover it. But I just give you the idea behind the proof. Okay, the idea behind the proof actually require what we call the fixed point theorem. I try to give you the rough idea. It's called fixed point theorem. Okay. And basically, at least most of the early days of proof is rely on this fixed point theorem. And probably ask, what is this guy? Okay, well, this guy is trying to say the following. So suppose you have a function that made from simple thing is the simplest thing is from real number to real number. Okay, or the even easiest is from 0 to 1 map to 0 to 1. Okay, the function map to itself. Okay, and the fixed point theorem said there exists one point such that the value of the function is function itself. That need not be, but need not be that. I mean, construction is one way to prove it, but fixed point theorem only require one thing, the simplest form. I mean, the special power fixed point theorem. Just saying that you put the value there after the function is still itself, and this is a fixed point theorem. Why? Because look at this graph. CO to 1 x. Right. This is CO to 1 here. Okay. And we say the function is mapping from 0 to 1, 0 to 1, right? So it must be, once you draw the graph, must be somewhere here, right? X is anything from 0 to 1. that f is also anything from 0 to 1, right? So if you try to draw a curve, right, maybe something here, okay, what is fixed point is look at the 45-degree line, 45 degree, okay? This is the fixed point because this is x and this is fx, but this is also x. Is that clear? Let me repeat. I think some of you is not getting because this is so important. Because the fixed point theorem is important later when we prove existence of Nash equilibrium and all the equilibrium. I think it's good to briefly describe here again. Okay. So this is x, f. Okay. This is x come from 0 to 1. Okay. And because the function is mapping from 0 to 1 to 0 to 1. Okay. So the f must be somewhere here. Okay. And fixed. Okay. And fixed point theorem said if f is continuous, okay, then you must have a fixed point. Fixed point means your input and output the same. Means that if a 45-degree line here, okay, you try to draw any function, you cannot skip this line. Okay. So what's the case? Suppose you start from somewhere here, right? You can start anywhere, right? You have to go, your pen keep going. I don't know how you go. You cannot jump because it's continuous, okay? You must have to pass this guy, right? You must pass through this guy, right? So this guy's fixed point because this guy 45-degree line, x, fx the same, right? 45-degree line. This is y equal to x, right? This line, right? So this is x equal to fx. This one. Okay. Is that clear for this one? So this is what we rely on the fixed point theorem. Okay. So we are going to, and this would also hold when you have this one dimension. Actually, this hold for n dimension. Okay. So how can you prove the existence of this? Okay. We will rely on what we call the fixed point theorem. As long we can construct the way we do is probably we'll spend some time to prove it. I don't know whether we should, but is to prove we'll do some construction. There exists a price, okay, satisfy. Let me see how to prove it. What we do is by fixed point theorem, we'll prove P star is actually solving this equation, okay? And by manipulating this equation, at the end, we can prove the excess demand is negative. Okay, so that is the idea of the proof. Okay, and I think I will skip the proof for this class. Maybe I will talk about it next class. But I think I want to define this. Okay, and then we'll talk about the proof next class. I mean, I think it's good to go over it because I think there are not many proof in our class. I think it's good to at least show you to some of the proof. Okay, because if I skip everything, then I mean, probably not good for you anyway. I mean, I will not ask in exam or assignment, but I think it's good to know at least to have some feeling of the proof. Okay, and once we prove there exists a price satisfy this guy, okay, there exists a price satisfy this, and actually you can, do I prove it? No. Actually you can prove that particular price, okay, would satisfy the associated problem. Okay. There will be a price, okay, and a vector of allocation that's feasible, such that this price associated with allocation satisfy the budget constraint, satisfy the utility maximization, and that is equilibrium. Okay, and in this thing, right, you just subtract that is required for the set. Right. Okay. So that is what we want to say. Okay, so that is what we call a Wahlstone equilibrium, is a vector of price, a vector of feasible allocation such this thing satisfied. And probably ask, is this thing exist? Okay, the answer is yes, on the condition this. Okay, if you assume utility continuous, monotone, C concave, then you have the price satisfy this one. Okay, and at this price, and you try to go to ask consumer to do maximization, the allocation will be what we call the market equilibrium. Okay, and this exists of proof to you. Okay, so, and in the next class we talk about why this is good by looking at what we call the first welfare theorem. Okay, but now we first prove, we will do the proof next class and try to prove to show you that this equilibrium exists, and then we'll show you this is a good equilibrium. Okay, so I will see you next week. Remember your homework to be due next next Sunday. Okay.